So we've been talking a lot about compound statements, and most of these compound statements that we've been talking about were pretty simple compound statements, right? They're all constituted by two simple statements. They only use one logical operator. However, you can get even more complex compound statements. So you can have an infinite amount of simple statements and compound statements that make up more complex compound statements. So one thing that's really important when statements get really complex is that you make sure when you're translating complex compound statements that you do so with the correct form, okay? So well-formulated statements in propositional logic are called well-formed formulas, okay? So well-formed formula, WFF, they're also referred to as WOFs, okay, are compound statement forms that are grammatically correct, okay? And you want to make sure that when you translate statements in ordinary language into propositional logic, that your statements in propositional logic are grammatically correct. Remember I said that propositional logic is basically a language in itself, okay? It's a logical language. So like any other language, it has a grammar, a syntax, okay? Now, first rule of the grammar of propositional logic to make sure that you have a well-formed formula is that the dot, the wedge, the horseshoe, and the triple bar symbols must go between two statements, either simple or compound, okay? So remember I talked about this a little bit in the previous slide. We always want to make sure that all the logical operators, which are connectives, okay, except for the negation, goes in between two units, either two simple statements or two compound statements, or one simple statement and a compound statement or something like that. But it always has to go in between, okay, simple statements or a mixture of simple and compound statements or a mixture of compound statements, okay? Okay, so here we have examples of well-formed formulas. Notice that we have here parentheses being used, okay? So we have parentheses P, wedge Q, parentheses, horseshoe, negation R, okay? This is one complex compound statement in propositional logic, okay? It is constituted by three simple statements, okay? Whatever statement that P stands for, whatever statement that Q stands for, and whatever statement that R stands for. And notice how here they're uppercase capital letters, so we know that they stand for a specific statement, okay? And then we have, in this area here, we have the wedge operator being used to bring together the two statements P and Q into a disjunction. Okay, and we know that this comprises a unit here because there are parentheses that bind these two together. Then, on this side of the conditional statement, we have the negation R, okay? And anytime you see a negation in front of a letter without any parentheses, this negation is negating only the letter that it is in front of, okay? So here you have a compound statement on one side, negation R, okay? And then here you have another compound statement on the other side of the conditional, which is P wedge Q, okay? And these two compound statements are being brought together by the conditional operator horseshoe, which means this conditional operator horseshoe is what's referred to as the main operator because it brings together the two largest units or parts of this entire statement, okay? And this statement then is a conditional statement because the main operator defines what kind of statement it is, okay? Here you have another well-formed formula. Notice you have on this side of now it's the disjunction that's the main operator because the two largest units that is being brought together is this here, the conjunction, and this here, the other conjunction. Okay, and these two units are being bound together by the parentheses. So this one is being bound by these parentheses, and this one's bound by these parentheses. Okay, and in these parentheses, you have the conjunction S dot P. Okay, so here you have a compound statement, and then here you have another compound statement Q dot S. Okay, and these variables here stand for specific statements. Okay, simple statements. So here you have two compound statements that make up the disjunction, okay, which is the entire statement, which is indicated by the main operator, which is the wedge, okay? Here you have examples of non-well-formed formulas, okay? So these are not actual statements in propositional logic. If you see something like this, you've done something wrong, okay? So what's wrong with this? Well, you have a logical operator that's not a negation. This is a dot, but it's not in between two statements, either compound or simple. Here's one simple statement, but there's no other statement, okay? So this is not a well-formed formula because that logical operator must be in between, okay, two simple statements or two compound statements or one simple statement, one compound statement, something like that. Okay, you have to have statements, compound or simple, on both sides of the dot operator, as well as for the disjunction operator, as well as the conditional operator and the biconditional operator. The negation is the only exception to that rule. Okay? Then you have here, again, you have a non-well-formed formula, so this is not an actual statement in propositional logic. Why? Because although you have two simple statements here, the logical operator is out here. It's not in between the two simple statements. Okay? So again, this is not a well-formed formula. Here you have another non-well-formed formula. This has the same problem as this one because you have the logical operator that's the horseshoe, the conditional, but it's not in between two statements, okay, simple or compound. It's right next to one simple statement, and you cannot have that, okay? And then here you have the same issue with this that you do with this one, okay, where you have two components, okay, you have two statements, but the logical operator is not in between them, okay? So these are not well-formed formulas. They are not actual statements in propositional logic, okay? So you have other rules. The second rule is that the tilde goes in front of the statement that it is meant to negate, okay? And I've talked about this in previous slides. You always want to make sure that the tilde goes in front of the statement, either simple or compound, that it is negating, okay? So here we have examples of well-formed formulas using tildes. So notice how here we have a conditional statement because this is the logical operator that is the main operator. The reason for this is because this is what's bringing together the two main components, okay, of this entire statement, okay? So the two largest components, here's one and here's another of this entire statement, are being brought together by this operator, which makes this the main operator, okay? Then on this side of the main operator, you have a compound statement. This compound statement is a negation, okay? And we know that it's a negation because the logical operator that reigns over this entire part of the entire conditional is the negation, okay? So it's kind of like order of operation, right? So you first have the components that are inside the parentheses, which are the smaller components, and then you have the ones that are outside the parentheses, which are the larger components that the smaller ones are embedded inside, okay? So here inside the parentheses, you have a compound statement, which is a disjunction indicated by this logical operator, the wedge, okay? And then this disjunction, the entire disjunction, okay, not just one letter, the entire disjunction is being negated with this negation tilde, okay? And we know it's the entire disjunction that's being negated because the tilde occurs outside the parentheses, which binds whatever's inside together as one unit, okay? Then on this side of the conditional statement, you have another negation, okay? Which is basically in this form, it's the simplest form of the compound statements. You simply have a simple statement that is negated, okay? And here notice how you have the negation in front of the simple statement that's being negated, okay? Here you have the negation in front of the compound statement that's being negated. And in this case, you have parentheses to indicate that what's being negated is a compound statement. And here you don't have parentheses because you don't need it, okay? Here's another example of a well-formed formula where we have negations, okay? So here we also have a complex compound statement in propositional logic. Notice that this statement is actually a disjunction. And the reason why it's a disjunction is because we have here the disjunctive wedge that's being used to pull together the two largest units of this statement, okay? So on this side, we have a conjunction making one unit, okay? And we know that it's a conjunction because inside the parentheses, we have the conjunction dot, which pulls together the statement S and the statement P, okay? And we know that these two statements are being pulled together by the conjunction dot because not only is the conjunction dot in the middle of these two statements, but the parentheses basically binds these two together. Then we have on the other side of the disjunction wedge, this statement here, which is also a compound statement, and this statement happens to be a negation. The reason why it's a negation is because we have a negation on the outside of these parentheses, which tells us that this entire side of the disjunction is a statement that is being negated, okay? So it's a negation. And inside this parentheses, what the negation is negating is going to be a conjunction, okay? And the conjunction is the conjunction of the statement not Q and S, okay? And not Q here, the negation is only negating the Q. And we know that the negation is only negating the Q because the negation is right out in front of the Q. Okay? And anytime you have a negation that's right in front of a specific letter, okay, that negation is only being applied to that specific letter. So the range of this negation is just that one statement, okay? However, if you, like this, you have the negation outside of parentheses, this negation ranges over everything that's inside the parentheses. And the largest unit that's inside the parentheses is the conjunction. Okay? So these are two examples of well-formed formulas that use negations. Here are examples of non-well-formed formulas that use negations, but they don't do so in the correct grammatical way. So these are actually not statements in propositional logic. So we've seen an example like this before. Here, this is not a well-formed formula because the negation is actually on the wrong side of the statement. Okay, so P represents a specific statement, and the negation, if it is negating the statement P, it should be on this side, okay, on the left side rather than the right side. Here we have the same issue here, although the issue here involves a compound statement. Okay, so the negation here is on the right side, and if this negation was negating this entire compound statement, which is a disjunction, it should be on the left side and not on the right side, okay? And then finally here we have another example of a non-well-formed formula that has negations in it. And the reason why this is not a well-formed formula is because although it's the case that you have a negation here out front, on the left side of the parentheses, okay, which indicates that what's inside the parentheses is a compound statement, and that's being negated, you also have here a negation on the right side of the parentheses. Now remember, negations are always negating a specific statement, okay, either a compound statement or a simple statement. So here we have this negation negating the entire compound statement, and here we have the negation negating this simple statement, okay? This is why you have to have the negation out in front on the left side of whatever statement the negation is negating. So here, having the negation on the right side doesn't give us any idea on what it is that negation is negating, okay? These statements, although they are not well-formed formulas, so they're not statements in propositional logic, they're also not statements in ordinary language, okay? Let's say that P is the statement, the grass is green, okay? So if P stands for the statement, the grass is green, then this here in ordinary language would say, the grass is green not, okay? And this is not a grammatically correct statement in ordinary language. It's also not a grammatically correct statement in propositional logic, okay? Consider this here, okay? So again, let's say that P stands for the statement, the grass is green, and let's say that Q stands for the statement, it is raining, okay? So if P stands for the statement, the grass is green, and Q stands for the statement, it is raining, then this here can be read back into ordinary language as the following. either the grass is green or it is raining, not. Okay? And that's not a grammatically correct statement in ordinary language. It's also not a grammatically correct statement in propositional logic. Now, let's consider this one here, okay? Now, let's say, again, that P stands for the statement, the grass is green, and let's say that S stands for the statement, the sky is blue, okay? If that's the case, then this here can be read in ordinary language as the following. It's not the case that both the sky is blue and the grass is green, not. Okay? And that's not a grammatically correct statement in ordinary language. It is also not a grammatically correct statement in propositional logic. However, with well-formed formulas in propositional logic, like this one and this one, it is the case that when you read it back into ordinary language, they will be grammatically correct statements in ordinary language. So consider this statement here. Okay? Now, again, we're going to say that P stands for the statement, the grass is green. Q stands for the statement, it is raining. And R stands for now the statement, roses are red. Okay? So if that's the case, this statement in ordinary language would read as follows. First, we would start with the word if, because this entire statement here is a conditional statement. Okay? So it would read, this entire statement in ordinary language would be, if it's not the case that the grass is green or it is raining, then it's not the case that roses are red. And that is a good grammatically correct sentence in ordinary language. Okay? It's also a grammatically correct statement in propositional logic. Okay? Now consider this one here. Okay? This one here, let's say that S again stands for the statement, the sky is blue. P stands for this statement, the grass is green. And Q stands for the statement, it is raining. Okay? If that's the case, then this complex compound statement, which is a disjunction, okay, because that's the main operator, will read as follows in ordinary language. Both the sky is blue and the grass is green, or it's not the case that it is not raining, okay, and the sky is blue, okay? And that is actually a grammatically correct sentence in ordinary language. It is also a grammatically correct statement in propositional logic, okay? The third rule for the grammar of propositional logic is that the tilde cannot by itself go between two statements, okay? So here's an example of a well-formed formula that illustrates this rule, okay? So here we have a statement, and this statement is actually a disjunction, okay, because the disjunction wedge, okay, pulls together the two largest units that make up this entire statement. The two largest units are P, the statement P, and not Q, okay? Now notice how in this statement, which is the disjunction, the tilde does not by itself go between two statements. Okay, so we have here a wedge operator and then the tilde. Okay, we don't have just the tilde. Okay, you cannot put a tilde only in between two statements. Why? Because then you wouldn't have a grammatically correct statement. Consider this. If we didn't have this wedge here, okay, then the statement would read, if we read it back into ordinary language, let's say that P is, again, the statement, the grass is green, and Q is the statement, it is raining, then this statement without the wedge here would read, the grass is green, it is not the case that it is raining. Okay? That's not a grammatically correct statement in ordinary language. It's also not a grammatically correct statement in propositional logic. Okay? So because it's the case that if we didn't have this wedge here, this would not be a grammatically correct statement, you cannot have the tilde in the middle, okay, of two statements. Basically, a tilde is not a connective like a disjunctive wedge or a conditional horseshoe or a biconditional triple bar or a conjunctive dot, okay? So conjunctive dots will always go in between two statements, either compound or simple. But the negation will always be in front of one statement, either a simple statement or a compound statement, and it negates that statement that it is in front of, okay? So here's an example of a not well-formed formula, okay, where you have the negation in the middle, okay? So notice how in this case, right, we simply have the P statement negation Q, okay? In this case, we don't have a grammatically correct statement because the tilde is not a connective. It doesn't connect two statements together. It actually is only used to negate a statement, okay? So you can't use it as a connective here. So this is not a well-formed formula. If you think about this, this also is not a well-formed formula in ordinary language. Consider, if we said that P, again, was the statement, the grass is green, and Q was the statement, it is raining, this would read back into ordinary language as, the grass is green, it is not the case that it's raining, okay? And that's not a grammatically correct statement, okay? You need something in between the statement, the grass is green, and the statement, it is not the case that it is raining, okay? So this is not a grammatically correct statement in propositional logic. It's not a well-formed formula. Finally, we have the fourth rule, which is that parentheses, brackets, and braces are required in order to eliminate ambiguity in a complex statement. And we've actually already talked about this a little bit in the beginning of this lecture, okay? So here's examples of well-formed formulas that use parentheses and brackets in order to disambiguate complex statements. So let's look at this example here. Okay, so this example here tells us that, number one, this statement is a disjunction. Why? Because the main operator here is the wedge. This is the logical operator that pulls together the two largest parts that make up the complete statement, okay? The first largest part is the simple statement P, which is on this side of the main operator. Then the next largest part is this here, the conjunction of Q and R, okay? So we know that Q and R make up one unit together, okay? Because of these parentheses. Now, because of these parentheses, we know that Q and R go together, okay? So in ordinary language, this would read, okay, in the following way. Now let's say that P is the grass is green, Q is it is raining, and R is roses are red. Then this would read in ordinary language, either the grass is green or it is raining and the roses are red, okay? However, if we didn't have these parentheses here, okay, so if we eliminated these parentheses, we wouldn't know if it's the case that this statement is actually a disjunction or if it's a conjunction. Because we wouldn't know if it's the case that Q and R made a unit or if P and Q made one unit, okay? And if P and Q made a unit rather than Q and R making a unit, this would be a completely different statement, okay? It would be a conjunction, which would be the main operator. So as a conjunction then, if the parentheses were over here, this would read back into ordinary language as the grass is green or it is raining and roses are red, okay? So we would have different statements here. So we need these parentheses here to tell us that Q and R go together as one unit, which then tells us that this statement here is actually a disjunction, okay? Here's another example where you have parentheses and brackets, okay? Now notice how here we have a statement that is actually a negation. And it's a negation because we have these square brackets here on the outermost of everything that's inside the square brackets. Then outside of that square bracket at the way end, okay, we have a negation. This tells us that this negation is the main operator and it is negating everything that's inside the bracket. Okay? Now, if these brackets were not here, okay, then we would actually have a different statement. Why? Because then this negation would end up in front of the parentheses here, which then would tell us that it is only negating whatever's inside the parentheses. Okay? Also, consider this. If we didn't have these brackets here, and we didn't have these parentheses here either, we wouldn't know what to make of this statement at all. We wouldn't know whether or not it's a negation, or is it a conjunction, or is it a disjunction, because we wouldn't be able to identify the units that go together according to the logical operators that are being used. So let's look at a couple of examples of non-well-formed formulas where the ambiguities show, okay? So here's an example here of a non-well-formed formula, okay? Notice how in here we don't have any parentheses, any brackets, okay? So in this case, we don't know what the units are that make up this statement, okay? We don't know if P, wedge, not R go together as a unit, and then Q, horseshoe, S go together as a unit, which makes the dot the main operator. Or if it's the case that P is alone, okay, and not R dot Q go together as a unit, okay, and then S makes a conditional with not R dot Q, okay. So we don't know if it's the case that this is a disjunction where you would have a parentheses bracket here, and then a parentheses here, and then a bracket here. Okay? So because there are no parentheses or brackets here, which tell us which parts of the statement go together as units to build up the larger statement, this statement is an ambiguous statement. It can mean various things depending on where those brackets and parentheses would go. So this is ambiguous. Okay? Here's another example here of not a well-formed formula. Now, although this has parentheses in it, the parentheses are not used correctly. Okay? So consider here. So we have the statement P, then wedge, then Q, and then we have a parentheses here in between the Q and the conjunctive dot. Then we have R and then the closed parentheses. The parentheses is supposed to bind units together, okay? And what I mean by units is they're supposed to bind statements together, okay? So what you should have inside of a parentheses are always going to be two statements, either simple or compound, and a connective, okay? Either a conjunction dot, or a disjunction wedge, or a biconditional triple bar, or a conditional horseshoe. Okay, it always has to be the case that when you have parentheses or brackets, what's inside them should always be, okay, two statements with a connective in the middle, okay? So notice here you have two statements with a connective in the middle, okay, and that's inside these parentheses. And then notice here again, you have two statements with a connective in the middle, and that's inside these parentheses. And here too, you have two statements with a connective in the middle, and that's inside the parentheses. Then inside the brackets, you have the same thing. You have two statements. Here's one, that's a compound statement, and here's another, that's another compound statement with a connective in the middle, and that's the dot, okay? Now here, we have the problem where we only have one statement and a connective, but no other statement, okay? So this actually is a misuse of parentheses, okay? And it's not a well-formed formula, okay? Okay, so let's look at some examples of things that may or may not be well-formed formulas, okay? And I want you to get a piece of paper out and write down the answers that you think are correct, okay? So for number one here, do you think that number one is a well-formed formula? Okay. What about number two? Do you think that number two is a well-formed formula? And number three, do you think that number three is a well-formed formula? And finally, number four, do you think that number four is a well-formed formula? Okay, let's look at the answers. You see here that number 1 is actually a well-formed formula, okay? And if you look at it, the reason why it's a well-formed formula is because it follows all the rules in order to be a grammatically correct statement in propositional logic, okay? So notice how, first of all, the negations here and here are used appropriately, okay? So the negation here is in front of, on the left-hand side of the statement that is negating, as well as here it is in front of, on the left-hand side of the statement that it is negating, okay? Furthermore, if we look inside the parentheses here and then inside the brackets, we notice that the parentheses and the brackets are being used correctly. First, inside the parentheses, we see that we have 2 statements and a connective in between those statements. Okay, so we have the statement Q, and then we have the statement not P, which is a compound statement, with the connective dot that's in between them. Okay, we also see that this negation is not by itself in between the 2 statements. Okay, so here we have the parentheses being used correctly because we have 2 statements, okay, along with a connective inside those statements. And we also see that the negation is not by itself in between 2 statements, okay? Furthermore, if you look at what's inside the brackets, we see that the brackets are being used correctly as well. Why? Because we have 2 statements. Here's one statement, the simple statement S, and then another statement here, what's inside the parentheses, which is a compound statement, okay, being pulled together by the connective wedge. Okay, so again, the brackets are being used correctly here as well because we have 2 statements, this one and this one, with a connective wedge in between. Okay, finally, we also see that here this horseshoe is being used correctly. Why? Because it occurs in between 2 statements. Okay, so here in between this bracket, this all here is one statement. It is one complex compound statement, okay? So here's one statement here, a complex compound statement, and here's another statement here, which is a compound statement, a negation, okay? And in between these 2 statements, this one and this one, you have the conditional horseshoe, okay? And that's also the case with all the other connectives. So this is a well-formed formula. Number 2 is also an example of a well-formed formula. Okay, it follows all the rules to be a grammatically correct statement in propositional logic. Okay, so here we see that, again, the negation sign here is being used appropriately. Why? Because it occurs in front of the statement that it is negating on the left-hand side. Okay, so the statement that this negation is negating is everything that's inside this bracket. Okay, and everything that is inside this bracket constitutes one complex compound statement. Okay, and we can break this entire complex compound statement into its smaller parts. Notice how inside this complex compound statement we have 2 statements being pulled together by a connective. Okay, so we have here another compound statement inside these parentheses, and then here another compound statement in these parentheses, and these 2 statements, this one and this one, are being pulled together by the connective, which is the disjunctive wedge. Okay, so these brackets are being used correctly. Furthermore, we see that these parentheses are being used correctly as well. So inside these parentheses, we have 2 statements, this one and this one, so S is a statement and R is a statement, which are being pulled together by the connective horseshoe, okay? And here inside these parentheses, we have the statement Q and the statement P being pulled together by the connective dot, okay? So these parentheses are also being used correctly. Okay, so all of this here, this statement is also a well-formed formula, okay? A grammatically correct statement in propositional logic. Now, these 2 statements are not grammatically correct statements in propositional logic, okay? So here, what is wrong with this? Okay, why is it not a well-formed formula? Well, first of all, you have an issue with the parentheses being used inappropriately, okay? Remember, The only things that you can have inside of parentheses or brackets or braces are two statements and one connective, okay? Notice here, inside these two parentheses, okay, you have 1, 2, 3 statements and 2 connectives, okay? So these parentheses are not used correctly, okay? Now let's look at this one. What is wrong with this one, okay? It seems like this one is almost right, okay? Except for the fact that you have here an issue with the negation, okay? The negation always needs to be in front of the statement that it is negating. So if this negation is negating the P over here, then the negation should go in front of that P, okay? So because this negation sign here is not in front of the P, this is not a grammatically correct statement in propositional logic, so it is not a well-formed formula, okay? Okay, so now let's look at some examples to kind of illustrate how we can translate statements from ordinary language into propositional logic, as well as identify the main operators, okay? So here we have two examples of compound statements, and we're going to first start with the first step, and that is to always identify the simple statements that make up the compound statement, okay? So here we have two statements. The first one reads, either Tracy or Becky owns a DVD player, but Sophie owns one for sure. Okay? Now the first step is to identify the simple statements that make up the compound statement. Okay? So we're going to go ahead and identify these. One of them is Tracy owns a DVD player. So I'm going to go ahead and underline that and give the statement Tracy owns a DVD player the propositional variable T. Okay? Then we have the second statement, which is Becky owns a DVD player. Okay, so that's the second simple statement. And we're going to give this simple statement the propositional variable B. Finally, we have the simple statement Sophie owns one for sure. And we're going to give that statement the propositional variable S. Okay? So now that we've identified the simple statements that make up the compound statement, we want to identify the logical operators. Notice that here we have either, okay, and we have or, okay? And either as well as or always go together, okay? So they constitute one logical operator. And the logical operator they constitute is the disjunction wedge. So we want to put the disjunction wedge where the or is, okay? Then notice here we have the word but. And the word but indicates the conjunction dot. So we're going to put the conjunction dot where the but is, okay? And now we have, notice, T wedge B dot S. However, this is not a well-formed formula because it's ambiguous. So we need to make sure to add parentheses in there, okay? And we want to add parentheses in order to correctly illustrate which statements along with the logical operator go together as one unit, okay? Now if you read the statement here, it says either Tracy or Becky owns a DVD player, okay? Then there's a comma and then it says but Sophie owns one for sure. Based on the statement, because it says either Tracy or Becky owns a DVD player, we know that this disjunction is pulling together the T and the B, okay? Statement T and B. So we know then that T and B make a unit together that's being pulled together by the disjunction wedge, okay? So we're going to put the parentheses around the T and the B, okay? Then we have here the conjunction dot and then S, which is fine, okay? So now we can see that this is no longer an ambiguous statement. This is a well-formed formula, okay? We have three things inside the parentheses, okay? We have two statements and a connective, okay? And we also have a connective with two parts being pulled together, okay? So this connective is being used properly as well, okay? Now that we have the statement in the propositional logic as a well-formed formula, we can go ahead and identify the main operator. The main operator, again, is the connective which pulls together the two largest units in a compound statement, or the negation, which is outside of the largest unit of that compound statement, okay? Notice here we don't have any negations at all, okay? So this is not going to be a negation. Now, in this compound statement, we have two large units. One is this one here, where everything that's inside the parentheses, and the other one is the S, okay? So because the conjunctive dot pulls together this large unit with this large unit, it is the main operator, okay? So this, I'm going to put a little star here, is the main operator, the dot, okay? And because the dot is the main operator, it tells us that this entire statement here is a conjunction, because the main operator identifies the type of statement you have, okay? Here's another example. Not both Suzuki and Honda are Japanese-owned companies, okay? So again, we want to first identify the simple statements that makes up this compound statement. And here we have Suzuki is a Japanese-owned company. That's one simple statement that makes up this compound statement. And then Honda is a Japanese-owned company. That's another one. Okay, so I'm going to give the statement Suzuki is a Japanese-owned company the propositional variable S. And I'm going to give the statement Honda is a Japanese-owned company the propositional variable H. Okay? Now that we've identified all the simple statements that make up the compound statement, we're going to identify the logical operators. Okay? So notice how here we have not. Okay? So we're going to replace the not with the negation. Okay? So we're going to put that tilde there. Then we have here an and we're going to replace that and with the conjunction dot, okay? Now, notice how we have issues with ambiguity as well here, because the question is, what is it that this negation negates, okay? Does this negation negate only the statement Suzuki is a Japanese-owned company, or does it negate the conjunction of the statement Suzuki is a Japanese-owned company and Honda is a Japanese-owned company? We have a little clue here by the both, okay? So both is telling us that the negation actually negates the conjunction of the two statements, okay? So then we would put parentheses around these two statements along with the conjunctive dot, because the negation negates everything that's in here, okay? It negates both the S and the H, okay? So now we have the statement that's a well-formed formula in propositional logic, okay? Now that we have a statement that is a well-formed formula in propositional logic, we can identify the main operator. The main operator will never be an operator that's inside a parentheses, okay? So notice here, the main operator was the conjunctive dot. It will never be this disjunction wedge because it's inside the parentheses. Remember, everything that's inside the parentheses makes smaller units that make up the larger unit. And the main operator is the connective that pulls together the largest units, okay? So whatever is inside the parentheses cannot be a main operator. This tells us that this dot is not the main operator, okay? What is the main operator then is this negation, okay? It's also the case that this negation, okay, negates everything that's inside the parentheses, which makes up one of the largest units of the entire compound statement. So this negation ranges over the largest unit that makes up the compound statement, which makes this the main operator. And I'll just go ahead and put a star there to illustrate that this negation is the main operator, okay? Okay, now let's look at one final example of a statement in ordinary language, and this is going to be a fairly complex statement, okay? So it'll be fairly long. So here's another statement in ordinary language, and this is a complex compound statement, and as you can see, it was a little bit longer than the first two that we just did, okay? So here the statement reads, if Julian does not become a lifeguard at the YMCA or get the job driving school buses, comma, then he will keep working at the bookstore in San Francisco and clean houses part-time, okay? So this is one statement. It's a very long statement, but it's still one statement, okay? And it's a complex compound statement. So what you want to do, first of all, again, is to identify all the simple statements that makes up this single complex compound statement. Now here we see that, and remember you want to identify the simple statements, okay? Negations are not simple statements, okay? So here we have Julian does become a lifeguard at the YMCA. That's one simple statement. And I'm going to go ahead and give that simple statement the propositional variable y, okay? Then we have Julian does get the job driving school buses, okay? And I'm going to give that simple statement the propositional variable b, okay? Then we have he will keep working at the bookstore in San Francisco, and we'll give that simple statement the propositional variable w, okay? And then we have he will clean houses part-time, okay? And I'll give that the propositional variable c, okay? So now we've identified all the simple statements that make up this compound statement. We want to next identify all the logical operators. So here notice that we have an if, okay? And this if belongs with a then, okay? So here we have an if, and the then is here, okay? So these two go together, okay? And they make up one logical operator. And we want to put that logical operator, which is a horseshoe, where the then is, okay? So we're going to go ahead and put the horseshoe right here, okay, where the then is. Next, we have the logical operator not, okay? So we're going to replace that not with the tilde. And then we find here the logical operator or, and we're going to replace that with the disjunctive wedge, okay? And then finally we have here the and we're going to replace that with the logical operator, the disjunctive dot, okay? So we have then here the following: not y, wedge, b, horseshoe, w, dot, c. However, notice that this is not a well-formed formula, okay? We need to now add parentheses in here to disambiguate the various statements, okay? And when we add parentheses, we want to make sure that the parentheses pull together the units that make up the larger compound statements, okay? Now, one thing that you can do is actually, when you see an if-then, okay, remember that if you have an if and then, everything that comes after the if, okay, before the then, will be the antecedent. So we know that everything from this point to this point makes up the antecedent of the if-then conditional statement. So that means that everything from in front of this negation to after the be will make up one unit, okay? Then we know that everything after the then in a conditional statement, okay, will be the consequent, okay? So we now know that everything after the then, which includes the W and the C, will make up the other part of the conditional statement, okay? So then we can put parentheses around those. Now notice we have a well-formed formula. Not only is it the case that we have a well-formed formula in propositional logic, we can also identify the main operator in this statement. The main operator, remember, is the logical operator that pulls together the two largest units of a compound statement, unless it's a negation, which is the negation tilde that ranges over the largest unit, okay? Here, the negation is not going to be the main operator because it's inside the parentheses, and it only ranges over, meaning it only negates this simple statement y, okay? So that's not going to be the main operator. However, we have here the conditional horseshoe, okay, which is pulling together this unit of the statement, okay, as well as this unit of the statement into a whole single complex compound statement, okay? So we know now that the horseshoe is the main operator for this statement, okay? And these are the two largest units that this horseshoe brings together, okay? So now that you have some idea of how to translate ordinary language into the language propositional logic and how to identify main operators, we're going to move on to the next lesson to discuss how we can actually now use truth tables in order to discover properties of statements in propositional logic as well as evaluate arguments in propositional logic, okay? I highly recommend that you practice translations for homework, okay? Because in practicing, you'll learn more and more about how or what it is that you need to do in order to properly translate statements in ordinary language into propositional logic, okay? If you have any questions, let me know during discussion.